Question number 3 is the ground state electronic configuration of chromium 2 plus H. 4 options are argon configuration followed by 4s1 3d5, next 4s2 3d4, 3d4 and 3d10. As I told you in the introduction, while writing electronic configuration, atomic number is important. Chromium atomic number is 24. Usually that number 2 goes to 4s and number 4 comes to 3d. But in case of chromium, there is a variation in the electronic configuration. Instead of 3d4 4s2, it has 3d5 4s1 as the outermost electronic configuration. So therefore, chromium has argon configuration followed by 3d5 4s1. In such options, first we need to get the required electronic configuration here and then go to the correct option. Look here, chromium is in +2 state here. To have chromium in +2 state, these valence electrons are to be lost. One 4s electron and one of the 3d electrons is lost in the formation of chromium 2 plus ion. So therefore, electronic configuration of chromium +2 ion is argon configuration followed by 3d4. This one electron and one of the 3d electrons are lost, 4 electrons remain here. This is the electronic configuration of chromium 2 plus ion. Once if you get this answer, try to search the answer you got in the given options. Otherwise, directly if you go to the searching of answer, slight variation in the answer will lead to the confusion. To avoid that confusion, get the required configuration, then try to get it from the given options. This is the answer we got, and this answer is there in option C. So therefore, correct option for chromium 2 plus electronic configuration is option C, argon configuration followed by 3d4. The next question is, in copper, atomic number 29, option A, 13 electrons have spin in one direction and remaining 16 electrons in the other direction. Option B, 14 electrons have spin in one direction and 15 electrons in the other direction. Option C, all the electrons have spin in one direction. Option D, all the electrons do not have spin. Look at the copper atomic number 29. This has the electronic configuration, argon configuration followed by 3d10 4s1. When I say 3d10 4s1, totally there are 29 electrons. Out of the 29 electrons, 28 electrons are paired electrons. In a pair of electrons, one electron has clockwise spin motion and the other electron has anti-clockwise spin motion. Out of 28 electrons, 14 electrons have clockwise spin and remaining 14 have anti-clockwise spin. But we have one more electron here, 3d10 4s1. That's unpaired electron. It has clockwise direction. Therefore, 15 electrons have one direction, 14 electrons have the other direction. Accordingly, the correct option is option B, 14 electrons have spin in one direction and 15 electrons in the other direction. So copper with atomic number 29 has 14 electrons in one direction and 15 electrons in the other direction. Come to the next question. The transition element X has a electronic configuration, argon configuration followed by 3d4 in its +3 oxidation state. its atomic number is option A 25, B 26, C 22, D 19. Look at the given electronic configuration. Argon configuration followed by 3d4. Argon atomic number 18. It's followed by 3d4 means 18 plus 4, 22. It is 22, but it is in plus 3 oxidation state. That means along with these 22 electrons, it has lost 3 electrons in the plus 3 oxidation state. So therefore, 22 plus 3, 25 is total number of electrons present in that element X. So the element X with this configuration in plus 3 oxidation state has 22 plus 3, 25 electrons. Therefore, correct option is option A 25. Look at the next question. Among the following series of transition metal ions, the one where all metal ions have 3d2 electronic configuration is, there are 4 options here. Titanium plus 3, vanadium 2 plus, chromium 3 plus and manganese 4 plus. Like that, titanium plus, vanadium plus 4, chromium plus 6, manganese plus 4. Titanium plus 4, vanadium plus 3, chromium plus 2, manganese plus 3, titanium 2 plus, vanadium 3 plus, chromium 4 plus, manganese 5 plus. To get the answer for this question, let us have the electronic configuration of these elements. The elements given are titanium, vanadium, chromium and manganese. We know the ground state electronic configuration of these elements. 3d2, 4s2, vanadium 3d3, 4s2, chromium 3d5, 4s1, manganese 3d5, 4s2. These are the ground state electronic configurations of the given metal ions. To get the answer here, we have 3d2 electronic configuration. If you take titanium, if this exhibits plus 2 oxidation state, it has 3d2 electronic configuration. Titanium in plus 2 oxidation state exhibits 3d2 electronic configuration. With this clue itself we get the answer. Look at the given 4 options. Amongst the given 4 options, it is the only option 4 which has titanium 2 plus. Look here, titanium 2 plus has 3d2 electronic configuration. To cross verify the other ions given here, vanadium 3 plus, here we have ground state electronic configuration of vanadium. To have vanadium plus 3, these 2 electrons and one of the electrons from here are involved in bonding. So therefore, vanadium plus 3 has 3d2 electronic configuration. Coming to the next, chromium, it is in plus 4 oxidation state. This 1 electron and 3 electrons from here are lost in plus 4 oxidation state. Therefore, it has 3d2 configuration. Let us check the last ion, Mn plus 5. Manganese in plus 5 state has lost these 2 electrons and plus 5 state, 2 electrons from here, 3 electrons from here, totally 5 electrons are lost. Remaining configuration is 3d2. So, titanium plus 2, vanadium plus 3, chromium plus 4, manganese plus 5. In short, in the competitive examination, we can't do this process because time factor is a major factor. One of the clue I gave here is titanium in plus 2 has 3d2 configuration. With that clue, you can select this answer. Another clue here is from one element to another element, one electron is added. When one electron is added, that electron is removed because every time oxidation number increases by 1 unit. So, therefore, the correct option for this question is option D.